Hi, we are Team 35 for the ACR 502 final project. I'm Zubin Kapadia, and our language is called Olaf because I'm a Counter-Strike player, and Olaf Meister is one of the greatest players out there at the moment. So this is in his honor, you could say. Anyways, so our language is pretty much like the syntax is pretty much like Java. So variables we support are, I mean, int and boolean right now, and the variable names could be alphanumerics, but with the exception of a variable name starting with a number. That's not allowed. And it's pretty standard stuff. You use equals to assign a value to a variable. One thing we do not support is multiple variables initialized at the same time, like the example you can see on the slide. Integer x comma y equals 1. That's not supported. Anyways, obviously all the statements end with a semicolon in our language because it's much like Java. And the arithmetic operations we are supporting right now are addition, subtraction, and multiplication. And the logical operators we have are greater than, less than, equals, less than equals, and greater than equals. We use a while for the iterative construct, and we also support if else as a logical constructs, and you could basically use if else in a nest both. You can have nested if or else and nested while loops as well. So one thing of a grammar that's different than Java is that after each construct, either if or while, the closing brackets should you should have a semicolon after the closing bracket. So that's one thing that's different in our language. Anyways, we also support functions and print statements. Print, you can either print a string, static string, or you could have an expression like a plus b, so it would take the value of a value of b, add them, and share the output. Functions can have any number of arguments. Obviously, the types would be integer and boolean only. And we also have a return statement. So if you have initialized a variable a as a function call, that is supported if the function returns the proper data type. Anyways, moving on. So for the grammar, each statement we have can be, as you can see on the screen, either a declare type statement, a logic statement. Logic would be if or else, a loop, that is while, a print statement, a function, or a function call. So when I say function, I mean a function declaration and function call separately. One thing I forgot to mention, that in our language you have to have the function declaration before you make the function call. So that's one constraint there. Anyways, moving forward in the grammar, we have a return statement that's used in the functions. The declare statements, we have multiple types. Either you can declare or just assign. So for example, int a equals 1, or that's a declaration, and an assign statement would be just a equals 1. So you could have int and boolean. So int a boolean a equals true or false. That's how it is as well. Anyways, moving on. So we have logic statements that are if. There could be two possibilities, only if and if with else, and as I mentioned, we do support nesting. Next we have functions. So the way you declare a function is right here. First you write fun func, then followed by the label, and within the parentheses we have any number of arguments you want, and the argument is defined the same way as in Java, a data type and label. So int a, int y, like that. Any number of arguments are possible, and after that there's a colon, and there's another data type that defines basically the return type of the function, and after that there are the curly brackets, and within that, that's a function itself. Okay, next we have alright, so function calls are different things. So function can be called using call and the name of the function, and then the parentheses, we have all the parameters that are required for the function, and the parameter is nothing but either a standalone number or an expression, like you could have 1 plus 1 or 1 plus 2, or a, or just a static 1. Everything is supported. Next we have a loop, so we support while loops, and that's pretty straightforward, just while. After that there'll be a boolean expression, that's just any equals. We check conditional operators, followed by the statements that are to be iterated over. Next we have the print statement, pretty straightforward. As I mentioned, we support two types of prints, either just a uh, static string or an expression. After that we have boolean expressions here of the types that I mentioned earlier, and on either side, left or right, you can have, it's not necessary to have just one variable. You can have a complete expression like a plus 1 plus 2 is greater than 3, or anything like that. uh, and finally, these are the leaf nodes that are just numbers and labels and stuff. So moving on, next we have our compiler. So we have used Antler to make this project, and so what we have to do in Antler is we basically define our grammar, and Antler takes care of it, and so it creates the lexer files, parser files, and etc. So right here what we have, we've just standard definitions of what lexer is, parser is, a compiler is. Let's just dive into code right here. Uh, so this is our G4 file that has the entire grammar that we just went over. Next we have, so right here. So we get the lexer file, as I mentioned, Antler generates that. We use that as an input for the parser file, and from the parser we can get the parse tree, and what we create is a visitor. So we give the parse tree to the visitor, and basically we get a callback at each node of the tree. So based on those, let's just show that, that'll be better. Here we go, the visitor. So as you can see, we get the override callbacks for each type of rule we have in the grammar: assign, expression, function, etc. So within these functions we can just define how we want to generate our intermediate code, which I'll be going over, I guess, in the next slide. So anyways, the parse tree generation. So let's take a look at this sample code. Pretty simple, just int a equals 1 and b equals 2. If a equals b, then print a is equal to b, or else a is not equal to b. So here's the parse trees. At the top we have program, then statements, and as we have here, there are two statements. Basically, first a declare statement. So statement is recursive, so at the top we have 2, then again 2, and so on. So in integer array, the declare statement is right here. I'm not really sure if you can see my mouse, but it's basically right there on the left. And then moving on to the right, we have another declare statement, as in b equals 2, and further on the rightmost side we have the entire if statement. So going down there we have the logic if else, that's the rule we have, that's a parent node, and in that we have if, then the condition, the statements for the if part, else, and the else part. Actually, let's just go back here and we could see another parse tree if we can. Let's just see that. Alright, so let's just take a simple code so that it's not such a huge tree. Just a equals 1 and b equals 2 and c equals a plus b, and finally print c. As you can see, this is our parse tree generated. I'm not sure if you can see that. Yep. Similar thing, the statements are recursive, so first statement we get is the leftmost, that's in a equals 1, and next is a, and b equals 2, and then here we have the arithmetics. So, and c, that's a declare statement, and under that the child node is basically an expression, so that it's a plus b, so that tells the compiler that it has to compute a plus b before it assigns it to c. That helps us while we generate the intermediate code. You could get something more. Oh yeah, by the way, I didn't mention that we do support brackets as well. So yeah. So here we have c equals a plus b plus 4 into 5. So as you can see here, right here, we have the declare int statement, integer c statement. So that's further broken down into just a plus b, then it multiplies. We'll look at the leaf nodes right here. So as you can see, a plus b is one of the leaves, so it will compute a plus b first, then 4 into 5, and then add both of them together. Anyway, I think that's enough for the past tree. Moving on, we have the intermediate code. So for the same example that the if statements, here is a sample, here's a bytecode that's generated for that. So we have a stack model kind of bytecode generation. So first it has a sign and a equals 1. So that takes care of push 1. So it starts from, first it pushes the right hand side and then goes on to the left hand side. And we use that logic in runtime that we'll cover later. Anyways, so push 1, push a and assign. So that tells me that I've just assigned a the value of 1. Similar for b. And as you can see, we have if statements and then comparison a equals b equal, and this is the else statement. I could show you, what I could show you here is, yeah, so these are basically the different types of codes that are possible for our intermediate code. So assign, we have here assign, add equals push, if, function, while. So anyways, this is the list right here. Anyways, I won't be going into that any further. What do we have next? So yeah, now one of my teammates Saurav will be taking over. So thank you.
Hi, my name is Saurabh Prakash. I'll be talking about the runtime and we'll be giving the live demo of our grammar. Our intermediate code is generated by the compiler. Our runtime takes the intermediate code as an input. It converts the intermediate code into a Java supported language in the JVM language. So basically, we are converting the intermediate code into a Java language, and we are running that code in JVM, and we are providing the output. We store like all the states, variable, address. In our case, address is the line number in a hash map so that we can track what is happening, what is the previous state. And also like we have if, else, while and function, and all of them has a jump statement whether to jump or not. So we store that in the all the previous cases in the previous state in the hash map so that we can keep track whether the jump we are able to jump or not. And if the condition is true, we jump, and if not, we don't jump to the address. So we get all this information from our hash map. Also in the function we have the caller and the callee. So basically callee call the caller, and then we have the we have to change the address. So to figure out what address to go and what address to come back, we use our hash map so that we can keep track whether to go and whether to come back. So let's move to the live demo. The tools in the project which we use is Antler and the Java, and let's go to the demo. So I'll be starting with a very simple one, which is hello world. So it will only print. To run our compiler, so basically we have a compiler jar. You do a java manage jar compiler jar, and as the argument to provide the uh, file name. So basically name we'll do a hello world, and we'll, so this compiler will generate the intermediate code, which is push hello world, and then we have a print. So basically printing hello world, and then we again print. To figure that out, we'll do a runtime to see whether it is happening or not. So basically we'll be running the runtime, and as the output you can see there is a hello world and there is a cause, that's a must. So we can see it's working, and we can also test it by changing the input. Let's do hello 2. Let's see whether it is working or not. So we first run the compiler, and then okay, compiler. So this is the grammar that is generated, and then we'll do uh, runtime to see whether it is printing hello 502. Let's move to the second example, which will be a simple maths example. So we have a declaration here, int a is equal to 14, then b is equal to 5, and here in the declaration itself we are doing the expression, basically multiplication, addition, and the subtraction. We have like c is equal to b into a, d, and then e, and we're printing everything that we have declared here. So here what we'll do is like we'll be running the compiler again with the file name as the argument, and the file is maths.olof, and we'll run it. So the intermediate code is generated. So let's check instead of going here. So you can see the intermediate code is generated. So instead of going here, I want to do the comparison. So I'll be taking, and here you can see we have like a is equal to 14, then b is equal to 5, and then a is equal to b. We are assigning everything, and here we have like a, b, and multiply. So basically a into b, then everything is going to the c, and same thing is happening here. D is equal to a plus b, and again e is equal to a minus b, and so on, and we are like in the end we are printing everything. So let's see whether it's working or not. We'll try to run the runtime.jar. Runtime.jar will be, so it's printing 14, 5, 17, 19, and 9. So if you see a is equal to 14, which is print a, then we have a 5, which is b is equal to 5, which is printing b. Then for the c we have a little bit of expression, which is b into a, which is 14 into 5, which is 70. We are printing it here. And then d is equal to a plus b, which is 14 plus 5, 19, and then again we have a minus b, which is e, which is 9. Okay, after maths, let's go to a if condition. We have a if and else. So here we are assigning two values, a is equal to 1, b is equal to 1, and we are checking whether a is equal to 1 or not. And if the condition is true, we'll print this, otherwise we print this. So let's try to compile it. So we'll provide the file name again, which is if else example. Then we'll see it generated the intermediate code. You can see the intermediate code is changed now. It has like a equal b equal not b. So I'll be using this to do the comparison. This is our if else. So this is our assign, and then we have a if start. So basically our if is starting here. So we are checking where a is equal to b or not. Here is our equal left. So basically this is our equal left. So we are checking this is a equal right, which is b, which is a. We're checking the condition which is left is equal to right or not, and then this is our if start. If this condition holds true, we'll start it from we'll start this, or else we go to the else and we'll do this. So let's see how it's working. Yeah, this is true. So a1 is equal to 1, so it's printing 2. If we change it to 2 again, if example, and a is not equal to 2, a is not equal to b. Yeah. And the next we have we'll be doing the nested if. So we also support the nested if condition. So here we are initializing a is equal to 5. We are checking whether a is equal to 5 or not, and then we're printing a is 5. Here we are checking any other condition inside this if, which is like if you see if this if we are comparing where a is greater than 2 or not, which is true. So should print a is greater than 2, and the end we are printing a is not 5. So let's see whether it's working or not. We'll provide the file name, which is nested if, and we'll compile it. It will generate the intermediate code. So basically doing the basic thing, push 5. Let me go to the nested if again. So basically it will doing push assigning 5. Then here our if condition starts, and then we'll go to equal between equal left. EQL is equal left. So we'll see it's comparing left is a is this right is 5. So it's comparing a is 5 or not. And then if it is condition holds true, it will do this, and it will do again there is a if. It will check this condition is true or not, and it will print a is greater than 2 or not. So let's see whether it works or not. We'll go to the runtime. We'll see the condition holds true, so it printed that. And let's also we can change something here, like this a is smaller than 2, it should not print a is greater than 2, and then we can see whether it is working or not again. It only printed the a is 5, so it skips that portion. Now we move to our, we have loop also, we implemented a while loop also. So it's very simple. We have int a is equal to 1, int b, int a is smaller than 10 or not. Here we are checking the condition. We have a print statement, and where here we are incrementing. So let's start with 1. So it should print like 1 to 10. Let's see. This is our compiler, so it will print this. And then we have a java jar runtime. Let's see, it should print file. So let me do it, like provide the file name, which is loop example. It will generate the, basically here it is assigning it, and then here it is pushing it. Here we are checking the condition is true or not. Here is the while start. If the condition holds true, it will start it here. Again there is a while and it will again go back here to check whether the value holds true or not. Time. You can see the output is 1 2 3 4 5 6 7 9 10. So let's alter the output a little bit, like a is equals plus 2. Again we are compiling the loop example, and again we are running the runtime. It's 13579 because the increment of 2. We are doing that. And now if condition doesn't hold true, so if, let's do it. Again we'll compile the loop example, and then if you do a runtime, it will not print anything. Finally, let's move to the function. We created a function, so this is the function definition, and this is the function definition with 3 arguments. The arguments a, b, and c, which returns an int. So basically, it's doing a plus b, printing the c, and return here. So basically, e is equal to a, and at the end we are printing e. So let's see how does it work. So basically, first we'll try to compile, and we'll try to provide the file name, which is function.example. Let's see, it created it. So the function is like push function asd. The function name is asd. We have arguments a, argument b, argument c, and everything we have here. And then we have the addition that we are trying to do here. Here the function start. This is the function start that we are having. That this is where it is right now. And then we have a add a plus b, which is storing in c, which is this. And then we have print c, which is this. And then we have a push a, and we have basically we are returning a. So our return is this, and this is the function. And again we have a asd, which is the function call, and then we are sending 3 parameters, param1, param2, param3. So 3 values 1 to 4, and we are sending it here. So let's try to run this. So it should print 3 and 1. So it's printing 3 because we have print c inside it. So from here it goes here, print c3. So c is a plus b, which is 1 plus 2, which is c is 3. And then we are returning a. So a will be here, and a will be 1, which is this. And then we are printing. So that's what our olof is. Thank you.